In this video, we will discuss the cosecant function and particularly how to graph cosecant functions. The cosecant function is the reciprocal of the sine function, written as the fraction 1 over sine of x. Like sine, cosecant has a period of 2 pi. We can explore the values of cosecant with the table shown here that includes sine values of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Let's start filling in the table by dividing 1 by all 5 values shown for sine of x. Remember that dividing by 0 is undefined. Thus, we get undefined, 1, undefined, -1, and undefined. Using x and y, let's now fill in the coordinates of each critical point if they exist. If the cosecant is undefined at a certain x, we will have a vertical asymptote at that value. Thus, we have a vertical asymptote at x equals 0, a critical point at pi over 2, 1, a vertical asymptote at x equals pi, a critical point at 3 pi over 2, -1, and a vertical asymptote at x equals 2 pi. Now that we've touched on some of the properties of the cosecant function, let's list a few more. First, there are no x-intercepts. Since the cosecant function is equal to 1 over the sine function and the sine of 0 is 0, the cosecant of 0 is undefined because we cannot divide by 0. Because of this, we know that the cosecant function has vertical asymptotes. Specifically, the asymptotes occur at integer multiples of pi, or x equals n times pi. Having values of x where the cosecant function is undefined means that the domain of the cosecant function is all real numbers, except integer multiples of pi. This means that, in the domain, x cannot equal n times pi, where n is an integer. The range of the cosecant function is the union of the interval -infinity to -1 and the interval 1 to infinity, where 1 and -1 are included in their respective intervals. As we've already briefly discussed, the period of the cosecant function is 2 pi. Y equals cosecant x is an odd function, which means it is symmetric about the origin. This means we know that the cosecant of -x is equal to the negative cosecant of x. Finally, since the cosecant function is unbounded, we can say that the graph has no defined amplitude. Now that we know more about the function, let's graph the cosecant function, and begin by graphing the vertical asymptotes for values of x from -2 pi to +2 pi. Think about what happens when x approaches the vertical asymptotes. Next, we should plot the points pi over 2, 1, and 3 pi over 2, -1. Remember to also plot these critical points with opposite sign coordinates given the domain of our graph. The cosecant function grows without bound in either the positive or negative direction, and there are no x-intercepts because cosecant cannot equal 0. Knowing this, we are now able to approximate the graph of the cosecant function as shown. Another way to graph cosecant is to use the related sine function as a guide. To do this, we first graph the sine function y equals sine of x and then draw the asymptotes that correspond to the cosecant function. Finally, draw the u-shapes between the asymptotes, noting that the maximums of the guide function are the minimums of the u-shapes and that the minimums of the guide function are the maximums of the u-shapes. Thus, we have graphed the cosecant function.